Oh yeah, this screencast is Chemistry AQA, and this time we're looking at the states of matter. And here are some retrieval questions, so you can pause the video here and have a go at these. Okay, so if we have a quick look. Number one, what are the three states of matter? Well, they're obviously solids, liquid, and gases. What is meant by the term boiling point? Well, that's the temperature at which a liquid changes its state and turns into a gas. Number three, what is meant by the term melting point? That's the temperature at which a change of state again takes place. This time it's where a solid changes into a liquid. Number four, which of these have the lowest boiling point? Covalent bonds, ionic bonds, or metallic bonds? The answer is covalent bonds, simple covalent bonds, because of the weak intermolecular forces. Number five, why is it important to know the boiling point of a compound? You can use a boiling point to determine its purity. So for instance, pure water boils at 100 degrees. However, if you boil water and the boiling point is 101, 102, then that is not pure water. There'll be some impurity in it. Moving on. So that's today's lesson, states of matter, and there's the learning outcome. So, have a look at these two. Pause the video here. What state will each of these substances be in? And then the second one, extension. What pattern can you see from this table? And what you need to look at is, as the number of carbon atoms per molecule increases, so the molecule's getting bigger and bigger and bigger, what's happening to the boiling point range? Okay, so moving on. Exam question, what is the state of oxygen difluoride at minus 200 degrees Celsius? So pause the video here and have a go at this. Okay, so looking at this temperature, that's when oxygen difluoride melts. So over here, it's a solid. When it gets to minus 224, it will melt into a liquid. So what is the state of oxygen difluoride at 200? Well, 200 is between these temperatures. Minus 200, sorry, is between these terms. So the answer will be, it's a liquid. Moving on. Pause the video here, and what can you say about these images? Okay, well, looking at this, you can see the particles in this one, in A, are in a regular pattern. They're tightly packed together. In B, there's no pattern. They seem to be spread out a little bit more, and they seem to be moving around. And in C, the particles are spaced out. There's not much force of attraction, hardly any force of attraction between the particles. And once again, they're just moving in a random direction. Below are particle arrangement and movement of each state. You can have a look at this. So in a solid, the particles are close together, meaning there's a very strong force of attraction between the particles. They're in a regular pattern, and they vibrate because there is some kinetic energy. And that's what you would be expected to draw in an exam. For a liquid, the particles are, once again, sort of close together, but they're not in a regular pattern. They're in a random arrangement. And they do move, which means they have a bit more kinetic energy than the particles inside a solid. And they are spaced out. And this is how you would draw it. And for a gas, The particles are far apart. There's not much force of attraction between them. There's a random arrangement, and they move quickly, so they have a lot more kinetic energy, and this is what you would draw in the exam. We'll move on. You can pause this video here and click on this link and watch this video. And then once you've seen that video, you can return back to this. Okay, after seeing that video, let's move on then. The state symbols. In the exam, you will be expected to use the state symbols. And this table tells you what they mean. Solid, liquid, gas, in solution, aqueous in solution. And you can see the state symbol, how they are used. What is the state of matter of magnesium chloride? Well, there's magnesium chloride. The state symbol says aqueous, or it means it's in solution. It's dissolved in water. Look at this one. Why does this happen? So what you've got a reaction between hydrochloric acid with sodium thiosulfate, makes sodium chloride, sulfur dioxide, sulfur and water. What happens is, this is where you start off. As the reaction takes place, so as the reaction is happening, clearly the X is visible. But as the reaction continues, the X is no longer visible. It disappears. Something has been produced that's blocking out the X. And the reason why X is no longer be seen is because of this. Sulfur precipitate is being formed. And we know sulfur is blocking out because sulfur is in the form of a solid. So that solid sulfur particles are blocking out the cross. And that's why the state symbols are important. Here you can see water molecules, H2O. Here's a water molecule, here's a water molecule, and so on. Here's another water molecule. And what you find is these are weak intermolecular forces. You can clearly see that. And it's the attraction between a positive charge there and a negative charge there. Explain why then water has a low boiling point with a reference to bonding and the force and the states of matter. 6 marks. Pause the video here and see if you can have a go at this. Okay, now what you should be thinking about is here. The relevant points you need to make are water molecules are covalently bonded. There are weak intermolecular forces between each molecule. So to break these weak intermolecular forces, not much energy is required. And because not much energy is required, it means it's got a low boiling point. And the particles become less dense and form a gas. So if you said all that, relevant points are identified, given in detail, and logically linked to form a clear account, you could get potentially between 5 and 6 marks. If you've only made relevant points are identified and there are attempts at logical linking, the resulting account is not fully clear, then you're looking at between 3 and 4, and then otherwise it's just between 1 and 2. It's a typical 6-mark question, this. Moving on. What are the limitations of these models? See, it's very easy to draw models to explain the point, but these models do have limitations. So pause the video here and think, what are the limitations of using these type of models? And if we think about this then, the limitations are, these models do not show the intermolecular forces. These models don't show the energy levels of each particle, and they don't show that all particles vibrate. Particles will have kinetic energy until you get to the absolute temperature, minus 273 degrees Celsius. When a pan of boiling water reaches 100 degrees, why does all of the water not vaporize at the same time? Here's something for you to think about. And that's the end of this screencast.